Good morning, everybody. Welcome back to lecture number 17. Today we will talk about what? Revision of how did we get the efficiency from the previous problem. How to get an efficiency? Remember, was this circuit 1 or circuit 2 or circuit 3?
2.
Circuit 2. Why? Because the parallel component is moved to the left. Is this referred to the primary or referred to the secondary?
Secondary.
Who said the primary? Raise your hand, that's okay. Why?
I confuse the which side is that.
Yeah, but here you read Vs, here you read Vp over A. So that's the easiest way to know. So I'm referring everything to secondary. That's one thing. To get the power calculation, if you read the question under these conditions, what is the efficiency? Efficiency always has to do with the real power. So we need to get the real power P output equal to S times cosine theta, where S is the 100 kVA. Cosine theta is the power factor, 0.85. So how many kilowatts? 85. How many resistive element in circuit 1? 3.
Okay.
In circuit 2, 2. One resistive element, another resistive element. If you use circuit 1, you have 1, 2, 3. Circuit 2 combines these two together. So circuit 2 is easier to do the efficiency calculation because I just need to multiply the current times the current square times the equivalent resistance. So if you want to use the exact model, you have to get the IP prime square times this plus the IS square times that. And then you'll get your copper losses. Nhas.
Okay.
Is this resistor copper or core? Core. Is it parallel or series? So to get the equation, I use V square over R. To get this, I use I square R. So because I'm using circuit 2, I'm multiplying 0.01 times IS square, which I already found. What is IS square? 361. Then I get the core losses, which is, if I'm using the circuit 2, it will be Vp prime, which is ES, we call it. Same. Over 60, square over 60. If I'm using circuit 1, it is the quantity EP that I did in the YouTube. It's not here today. So basically I divide, we call this in circuit 1, what did we call it? ES. Or I call it EP prime, because everything is referred to secondary. So I divided EP square over 60. That's the accurate one. That is what simulation softwares are doing. Simulation software is doing. Get it? Great, get it? So if you work with a simulation software, are they going to use circuit 1 or circuit 2? Circuit 1. So which one is more practical? In real life, more useful, more accurate? Circuit 1. Circuit 2 is to skip analysis faster.
السكيب هذا راح يأثر في الناتج النهائي بشكل كبير ولا؟
No, 3-5% only that. So if you combine them, you will get 85 over 85 plus losses. So the efficiency is 96.86%. Is this a good or bad transformer?
Good. Very good.
Good.
Average.
Average, that's the proper way. But okay, is the engineer bad? No. Okay. Is the transformer good or average or bad?
Good.
Good. No, it's average. Because remember, for transformer between 0.9 and 0.99, this is A plus. This one is barely C plus. So the 0.96 is B, average. But the engineer, anything below 0.8, no, that's great. That's good engineering. Anything below 0.8, that's a bad engineering. No, below 0.9. Basically, if you design a transformer of 0.8, don't use it, okay? Check Amazon. Is there a transformer with 0.8? I don't know. Example 5 is very similar to example 1 if you want to practice for the quiz. Are the numbers the same? Can anybody check example 3?
3 1 1.
3. VIP example. They're the same?
No.
Is it the same?
لا 0.04.
Can you compare this with example 5? Whatever. يا شباب easy question. هل هذه أرقام نفس example؟
Yes.
Match?
That's fine.
Yes. Okay. Then no need to explain it. We save time. So this is the same example, but the only thing I want to show you is what if we do it with circuit 2? We do it with circuit 2, how many KVL? So let me draw my favorite table. My table is the following.
دكتور على فكرة انت قلت انه اللي ما حيسوي سيركت 1 حيسوي سيركت 3 صح؟
Pretty much, but what if I ask you to do circuit?
Oh.
Yes, you have to know everything. So circuit 1, circuit 2, circuit 3. If you get stuck, use circuit 3 because circuit 3 is you just need 1 KVL,
Okay.
0 KCL. Okay? For circuit 2, you need 1 KVL, 1 KCL. For circuit 1, 2 KVL, 1 KCL. And the KCL is basically it's going to be in form of IP prime equal IE plus IE prime plus IS, or if you refer to refer to primary IP equal IE plus IS prime. Those KCL. Get it? Yes. So in this example, he used the KVL, which is plus VP minus I times those impedances minus VS. Is this AVS or VS prime? That is AVS prime, same. Is this referred to the primary or referred to secondary?
Secondary.
Wrong.
Primary.
Get it now?
I think yes.
Get it?
Yeah.
If you see VS prime, then it's referred to the primary. If you see VP, basically if you see just the VP, then you're referring to primary. If you just see just a VS, then you're referring to secondary. Or the impedances. The A squares are multiplied by the secondary, so you're referring it to primary. Or if you see RS prime, XS prime.
دكتور الافشنسي لما اجي احسبها في البرايمري والسكندري كلاس تفرق ولا؟
No, it's the same. As long as you are consistent, they should be the same. Okay? Okay. Let us see what did he do. So he calculated the VP, he got it to be 476. If you do the exact circuit, it was I think 478 versus 476. So the difference is 0.3%. Clear? So the VIP example now is solved in the slide using The other method. I didn't know that they are the same, but I'm going to keep it. Because in example 3, we didn't write a solution in the slides. So now there's another solution in the slides. And circuit 2 is used in the slides. So that's a VIP example. It will come in the quiz maybe. Example number 6, and I probably need to take a water break if you allow me. Are you guys going to study module 1 again? So quiz 3 is going to be what? Mini major. Because our major October 22nd. And I don't think you are studying. So we'll have quiz 3 as mini major for lecture.
بس كويس 2 بس موديل 2 صح؟
Quiz 2 is from slide 1 until slide 91.
Okay.
Mini major will be what? From major 1, yes. That's a mini major. That's the only way for you guys to study. Because you ruined it for quiz 1. Now I don't think you passed quiz 1. So that's the only way to study for the major. We have quiz 3 as a mini major. And quiz 3 will be few days before the major. Maybe October 10, around that. Then maybe we'll have quiz 4 right before the major. I'll give you quiz 4, solve it, and then I give you the major. You don't want to have more quizzes? 15%. You have 3 quizzes, it's 5% each. More is better, trust me.
مجرى الساعة كم؟
Usually after 6 p.m., 6 or 7.
Doctor, this mini major will have a high balance?
No,
The same?
no, same. It's a quiz. It's a quiz, mini major.
The word mini it's for the
Many, it means
the chapter.
it covers module 1. That's the only way to study. Otherwise, I can leave you until October 15 and then you don't know what's happening. It's good for you, trust me. You have, and then you have many majors, so that when the major comes, you know how to solve it. Let's look at this example. Example 6. Is this a single phase or 3 phase?
Single.
So did we see a 3-phase transformer or not yet?
Not yet.
Not yet. So this is a single phase, 10 kVA. Is it a step up or step down? Is this line to line? Correct. There is for single phase. Don't bring the word line to line. No need. It doesn't exist because we only have one line. هذا الشيء مختلف عن السنجل فيز equivalent circuits اللي كنا نشوفها في موديول 1. هذه كان عندك already 3 phase system بس انت you draw a single phase equivalent. When you go to the power calculations data, you still see a 3 and square root of 3. Please, I was upset when I graded quiz 1. Quiz 1 was not good. Okay? Study it, okay? And study the other sections, quiz 1. Single phase transformer. Let me ask you a question. Are those parameters for circuit 1 or circuit 2 or circuit 3?
Circuit 2. 2.
Think. Who said circuit 1? Is there RP? Is there RS? Can you combine? What does EQ mean? What does EQ mean?
Circuit 2.
Equivalent.
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 Yes.
EQS. What does the S mean?
Secondary.
EQ means equivalent. S here means refer to secondary. But what is this? This one is nothing but RP prime plus RS. Get it?
This is second circuit. Circuit 2 صح؟
It's circuit 2 refer to secondary. So from the parameters, you should know which circuit to use. What is this? X of equivalent S. It means X P prime
Plus.
plus
X.
X S. That's the professional way of reading the data sheet. When you are in the field with Aramco, inshallah, nobody will tell you what are those parameters. And then you submit a report, you refer the transformer to the primer, and then they laugh at you, and then you stay with the same job for the same 25 years, no promotion. Because you didn't pay attention in E360. Or a mechanical engineer who has 2 or 3 years of work experience will teach you transformer. Imagine. So please learn from the data sheets. As every manufacturer, they have their own data sheet. What is RCS? Mu'ad, what is RCS?
RC refer to second.
What is C stands for?
اللي في النص.
Copper.
كم.
اللي في النص copper.
ايه اللي في النص.
لا مو copper. Core.
الكور.
Copper we usually put Cu. C is core. Get it? We're here to learn. That's okay. So هذا اللي في النص refer to secondary. Can I recall it in our thing RC prime?
Yes.
And this one same. XM prime اللي في النص. Okay? Circuit 1 or circuit 2 or circuit 3? Now, in your paper, who doesn't have a paper? Okay, in your tablet, draw this circuit to me. If you don't have a tablet, use your quiz paper. Write in your quiz paper on the back and show it to me. If you don't have a pen, get from your friend. I want to see it right now, please. Draw circuit 2 with all VP, ICS, etc. Not ICS, IS primes, etc. We have a quiz the day after tomorrow, and you will be asked to draw the coordinates. No, open a new page. You don't use notability. Circuit 2.
حتى الكفر حيصير له reference.
No, when we say copper, usually على efficiency, we're not here.
بس ليش
And I was explaining to Mu'ad that C doesn't mean copper. C means core. Cu means copper. This is just side information. ايش هذا؟
طب دكتور الكور كمان حيصير له كمان هذا؟
The core is usually referred to primary, but because we refer all the primary components to the secondary, it has to have the prime or subscripts.
طب حيتغير رقم يعني لو انا اسوي
هذا already متغير, already مقسوم على A square. Get it? That's why I'm teaching. These things are what students make mistakes. Draw the circuit. You have a huge problem. Is this circuit 1? Where are the units? Okay, where are the currents? What is this current? What is this current? When I asked you to do circuit 2 in the quiz, what is this thing? Okay, where is VP, VS? Terminal voltage. Don't forget terminal voltage. That's correct. Now use the same letters they have there. Use, just to illustrate or understand. It's professional. Well, you can use the same letters that we told you. That's good enough. Circuit 2, huh? Where is your circuit? Where is the terminal voltage? The incomplete. See, in the quiz, if you don't write every information, then it tells me that you memorize, you don't understand. Why are you drawing circuit 1? This is circuit 1. It's wrong. Quiz will be hard. You have to study for it. Then go to the side. Anyway. What is this circuit? Why do you call it V1 and V2? No, that's wrong. We call it VP. No, that's wrong. VP prime. That's the proper way. What is the current here? What is the current there? And this is wrong. This is not RM, RC. What is this? M or C? RC, S. What is this? XMS. What is the current here? What is the current there? You got the idea. Okay. So the circuit is this one. Okay? Quick question. He wants the efficiency for full load. Full load, 75% of full load. What does full load mean? Full load means the whole apparent power, 10 kVE, is utilized. 75% of the full load, it means 75 kVA refrigerator is connected. Full load معناته 10 kVA refrigerator is connected. Which one is bigger? 10 kVA or 7.5 kVA? 10 kVA, that makes sense. So, 0.8 power factor lagging, leading, 0.6 power factor lagging. What do I learn from these information? Theta I and theta, as well as the real power. So what is the real power here? Is S cosine theta, صح?
Yes.
So it is what? 8 kilowatt. In part B it's also 8 kilowatt. In part C 0.75 times 10 kVA times 0.6 kilowatt. So I can learn from these information, chapter 1 or module 1, the real power here is 0.8 times full load, 0.8 times full load, A and B are the same. C is you're operating the ثلاجة اللي 7.5 kVA at 0.6 power factor. It means 7.5 times 0.6 or 10 times 0.75 times 0.6 kilowatt. Calculators, what is this number?
نفس الشيء اللي فوق صح؟ 10 times
A و B نفس الشيء.
10 times cosine 0.2.
Yes. What is part C? Calculators? 1.5 4.5 kilowatt. تفضل.
كيف لاقي وما في كباستر؟
لاجنج وليدنج ما لها علاقة بالريال باور، لها علاقة بالثيتا.
بس كيف ما في كباستر بالسيركت؟
No, this circuit هذه على part A يعني. هنا اللود will be connected. Capacity.
ولازم يكون في كباستر
كيف؟
عشان يصير لاقي الباور فاكتور لازم.
No, هذا لاجنج هذه اللود عبارة هذه مو ثلاجة، هاي شيء هذه كاباستر.
مكان اللود كباستر.
Yes. مكان اللود كاباستر. هل في ثلاجة لاجنج ولا ليد؟
ليه؟
Why? ثلاجة لاجنج inductor. Okay. Most of the loads are inductive. Okay? Unless you see a capacitor in it, then it's capacitor. Okay?
بس هو اصلا في جهاز حيكون كاباستر ليش يعني؟
There are loads that are capacitive.
Like microwave. Microwave lead.
No, I don't know.
Yeah.
The nature of the load, distribution of them. Maybe it's a research problem for you. What are the real examples for capacitive loads? Capacitor banks are capacitive.
ايه بس البانك انت تستخدم عشان تسوي ستور انرجي مو عشان تسوي جهاز
Not
ولا
really.
شيء.
Capacitor load banks to inject bars in the system. Don't store energy. Now, what is S 10 kVA? What is the current? 10,000 over 220. Refer to secondary. 45. What is theta? Is for part A, is it leading or lagging?
لاقي.
Lagging, so it's plus cosine inverse of 0.8. What is theta I? Is theta V minus theta. What is theta V? 0 minus cosine inverse of 0.8. So this number is for the IS. Get it?
Yes.
Get it now? Because you're taking this 220 as a reference. So theta V
الزيرو.
is 0. So this implies theta I is minus whatever, 36 degrees. Okay? So I'm doing the 1 kVL, which is this kVL, under this equation, and I got 232 angle 2.1. So the voltage from Saudi Electricity Company is higher. Then I get the copper losses. What are the copper losses? What is this number? 45.5 square times REQS. You'll get this number. As a matter of fact, this should be CU, okay, to be specific. Copper. For core losses, we get the VP over A, which we can call it ES or EP prime, because we're using circuit 2, which is the 232.47 square divided by the 484 RCS, which we call it RC prime, 484. Then you do the efficiency. What is the efficiency? You can use this equation, or you can use S cosine theta, which is what? 8 kilowatt. So 8 kilowatt here, 8 kilowatt here, plus the losses. Is this good or bad or average transformer? Average. Is the engineer pass or not pass? Pass, okay? If you do part B, the only difference is this angle becomes plus 36 because it's leading. Same equation. Same.
We put minus at the beginning.
No, because theta is what? Minus cosine inverse of 0.8. So theta I will be 0 minus cosine inverse. That's why. It's not only that. You notice the voltage magnitude is 215. It's lower. So if I connect a capacitor bank, which is a capacitive load, and Mashabi will tell us, maybe now or later, what are examples of capacitive loads in real life. Omar, he says microwave. I don't know. Is the microwave capacitive? البوينت هنا ان الفولتج هنا اقل. Then if you do the calculations for copper, you get core losses that are smaller, because core losses are related with this voltage over R, so it's smaller. So, but you still get efficiency of 96.2, which is still average. In the third part, he didn't use the full 10 kVA. Haj, what did he use in the third part? 75% of the rated apparent power. For your S in this problem, we call it S out because for transformers we have Sn equals S out. So if your load is at 75% of the source, then your apparent power is 7500 VA. This will change your IS to be smaller. It was 45, now it's what? 34. It's not only that, you still get higher voltage, 230 higher than that. So in this question, to get the efficiency calculation, we got efficiency to be 95. Because whoever connected the load, oversized. If you have an oversized transformer on a refrigerator, you're not going to have higher efficiency. So what is the lesson learned? The transformer designed for 10 kVA, it's better for you to connect a load that's 10 kVA. If you connect a load, if a transformer 10 kVA, you connect a load of 7.5 kVA, you are oversizing your transformer for that load. The price you pay's efficiency will not be optimal. So what did we conclude? Transformers are designed to operate at the highest efficiency at rated values.
دكتور يعني منطق انت تتكلم عن ability power صح؟
The efficiency has nothing to do.
لا بس انا ما اجيب اقل من ability power اللي هو بيعطيني يعني ليش الافشنسي بتتغير؟
تتغير لأن relatively the core losses and copper losses will be high. You still need to run this transformer. Don't think of transformer as a dead animal. It's not a dead animal. It consumes power. The transformer itself فيه له magnetization, فيه له copper, فيه له core. If your load is 7.5 kVA, why not bring a smaller transformer from the beginning? That's why the efficiency is low. Would it still work? Yes, it will work. Is it a difficult problem in your life? Yes.
بس انا يمكن ما اعرف اللود حقي كم يمكن استهلك.
That's what Saudi Electricity would guess.
يمكن استهلك.
They would make load analysis, estimation. Based on that, they will buy the proper transformer near your house. So, is it an optimization problem? Yes.
لانه الترانسفورمر في الاحياء يمكن تيجي في بعض الاحيان الطاقه تكون اقل او اكثر.
Well, most probably it has to be more. So that's why in real life, most transformers, they operate below average maybe. Would you rather operate at 93% efficiency and your customer is happy? Or operate at 99% and your customer cannot connect certain loads? It's your choice. Now we bring a question about economics, but you get the idea. Enough talking about that. We have the last 5 minutes. Let's talk about what? Three-phase transformer. Let me ask you a question. You are an engineer, you have single-phase transformer. What is the laziest way to have a three-phase transformer output? Laziest way. You don't know how a three-phase transformer looks like. What is the easiest, laziest way? Easiest and laziest. Three transformer, you're right. So can I bring one single transformer in place here, another one here, another one there? Can I do that?
Yes. Why not?
Why not? Or can I have a box, I don't know what's inside it, where I have
3 wires.
3 wires. Or if I'm using line to line, هذه مو microchip. So this one I have V phase A, VB, VC. Here I have VA, VB, VC, but here AN, EN, CN. I can have 6, well, I don't care for now. So let's say you measure these 3 transformers, how they look like. Are they reliable? Yes, because I can put a wall between them. If this explodes, the other 2 will not be harmed. Transformers do explode in real life. And an interesting thing or interesting story, in the recent 100 years, when there is an earthquake, zilzal, people see blue lights near substations. I was reading about it. I really don't know the answer. لكن هي ظاهرة اللمبات الزرقاء اللي في الزلازل. Some people they say we have lived enough to have transformers. So all the documented recent history about this incident is due to transformers. So transformers blow up, they will have يعني arc flash والكلام هذا. That's the reason of the blue lights. Another school of people, they claim that those blue lights are existing even before electricity. And these are from the friction between the earth, تفريغ الطاقة. So I don't know who's right, but it's a problem that's worth exploring. But it is true, if there is an earthquake and you hear an explosion, it's usually transformers. Are they easier to transport? Yes. عندك تحمل 3 ترانسفورمات صغار في تريلر. It's easier to put them than a big giant transformer. And also you get the spare phase. If one fails, the other will still work. What if I tell you I can have a single core, 3-phase transformer? How many cores do I have here? 1 core.
Okay.
It's shaped يعني مربعين. 3 legs. Every leg is a phase. So you put VA here, you get it here. B here, you get it here. C, you get it here. Again, if you put a voltage here, you get a flux here, the opposing flux this way, so you will get a current coming out. Lenz's law and the other guy, Faraday. Is it cheaper? Yes, because you don't do 3 manufacturing processes. You do it 1. It's lighter. And 1 transformer is lighter than the 3 transformers separately. Well, what's the problem? You need 1, يعني بدل ما transformer to put it, you need a crane that's weak, you need a stronger crane to put it. Smaller, bit more efficient, and it's used. What's the problem? If you get a failure here, everything is messed up. And you cannot have the walls. Can you have the walls in a single core 3-phase transformer? No. You cannot have walls. Now, how do we connect them? Oh no, before that, the ratings. How do we read the ratings? 100 MVA, this is the apparent power for 3-phase. It means per phase is what? 100 over 3.
Okay.
Now again we bring, for 3-phase we love line to line, صح?
Yes.
So now we love to line to line, we love to line to line. What does it mean? It means this voltage is not VA, this is VA minus VB or VAB. This is for primary, this is for the secondary.
كيف تعرف إنه هذا 3 phase ولا 1 phase؟
He will tell you on the power. He will tell you. Let's say you connected Y to Y. What is the voltage here between A and C? VAC. So if he tells you this one is 13.8, it means you have here 13.8. What is the phase if you connected Y? 13.8 divided by square root of 3. Agree with me?
Yes.
Yes.
Same for the output. So if you take the ratio of the blue over the blue, or the red over the red, or the black over the black, you will get VAN over VN, which is A, correct?
Yes.
Even if you take a line to line to line to line, the square root of 3's will cancel. So you will still have it as A. Because this is square root of 3 times VAN over square root of 3 times VAN. Then the ratio will be the same. The key here, in an A you start مع الphase, مع الcoils. Then you go to line, which is square root of 3 VAN over square root of 3 VAN. Y to Y they will cancel. I need you for 1 minute, sorry. How to connect it in real life? In real life, you go here, draw a line, هذا skip, هذا Y, skip. You can leave if you want. Same for here. We connect the lower coils together, tie them together. Will A, will B, will C, they will be your terminal. So you have one terminal here, one terminal here, one terminal here. هذه كلها connected على neutral, maybe ground. Get it? So that's why we love line to line. Do you understand now why we love line to line? Because if you connect the transformer, you still have access to the line. Next lecture will continue and we'll have that quiz. Okay? Can you check the camera?